Hello, calculus students. Your test number one is coming. It's going to cover the first 5 sections of the book. And so I will just briefly go over these review problems. Okay, so let me share my screen and we'll get started. You will be able to access this checklist. All right, so this is a checklist for test number one. It's basically called practice test number one. So if you look for the item called practice test number one under your module, that's the chapter 2 module, you'll find this blank sheet of paper. It's not blank sheet of paper. And what I mean by that, it's a sheet of paper that does not have the answers. Okay, so I have 13 questions here. I have several vectors and points and planes, and all the questions are pretty much based on these. And then later we have, in addition to these, know this and know that, okay? So that's, I'm not gonna go over everything in detail because I do have these answers written down under what? Practice test number one answer key, right? No, not a very surprising title. And so let's go over the questions one by one. All right, so number one, find the exact expression for the angle between PQ and PR. PQ is right here, and PR, you have to find out what PQ and PR are first. All right, and then you may want to just ask questions like this to yourself. All right, I'm supposed to find the angle between two vectors. What am I supposed to use? Okay, and the answer, I hope you know, is the dot product. Okay, so here's your PQ and PR. All right, so you need to calculate these. And then you know that the, well, what do you remember about the dot product? The dot product of two vectors u and v is equal to the norm of u times the norm of v times the cosine of the angle between them. So if you solve that for the cosine of the angle theta between them, you get u dot v divided by the norm of u times the norm of v. And so you apply that formula and then you take the dot product of these, that's, this times this, 3 plus 0 plus 6. That's going to give you 3 plus 6, which is 9, over the square root of this. And, this is an okay answer, right? And in other words, if you want your answer to be the theta, which is the inverse cosine of this, I will give you full credit. Although, when you think you can simplify, you probably should, because you may get some additional information about the angle theta. All right, so if you simplify this, and I told you, you do not always have to rationalize the denominator, but you can. And in this case, you get a very nice, very familiar number, square root of 3 over 2 as the cosine of the angle theta. And of course, from here, you can conclude, of course, theta is between 0 and pi, or 0 degrees and 180 degrees. So that angle theta has to be pi over 6 or 30 degrees. And so now you can never get that information just by looking at these, right? So this is an advantage of using the dot product, right? Okay, number 2, find the area of the parallelogram. Let's stop here. How do you find the area of a parallelogram? Where the two adjacent sides are two given vectors. Okay, so you have already calculated PQ and PR, and then you tell yourself the area of the parallelogram is, yeah, it has to do with the cross product, right? And in fact, the cross product is a vector, so that itself is not the volume of the area, but you take the norm of the cross product, and from here, you can take the cross product, right? So it's this times this minus this times that, -3 minus 0, which is this. And the next one is this times this, -3 minus this times this, -3 minus -6, and that's +3. But remember, this one will take on an extra negative sign, so this will be -3. The last one will be 0 minus this times this. That's 0 minus -1 times -3. That's -3. Sorry. So that would be -3. So that's a sort of an interesting vector here. You take the norm of that, and that is square root of 27 or 3 square root of 7. Okay, and this will always be a positive number unless these end up giving you the zero cross product. Incidentally, if you recognize this as this, I mean this is fine too, right? If you want to take the norm of this, you can take that absolute value of that scalar out and figure out the answer also is 3. That's going to be the same answer. So in order to calculate the magnitude, if your vector is a scalar product of a vector, you can take the scalar out, and then you can also find the answer that way. All right, number 3, write an equation of the sphere centered at P. So here's my P. So you'll have an expression like x minus 3 and y minus 0 and the z minus 1. And then with a radius 6. So the other opposite side will be 36. That's a pretty easy question, right? This will be acceptable. I will, not that, it just disappears. But I can undo this. All right, so this is completely fine. I'll give full credit for this. If you multiply this out, you will actually get this, and that is also an acceptable answer. I will take either one. One is not better than the other. So, all right, number 4, find the unit vector in the direction of the sum of a plus b. How do you find the unit vector of a vector? Okay, and you should be thinking of one word. What is that word? Normalization. Okay, that process of getting a unit vector in the direction of a given vector is called a normalization. Very simple. All you have to do is to find the norm of this and divide that vector by it, right? So first you add these two, and then you divide it by the norm of the sum. When you add these two, you get 1, -2, 1. And so you take, well, of course, what you will do is take the square root of 1 square plus -2 square plus 1 square. And that's, of course, square root of 6. And you divide each component by that number. You could also write this way. No problem with that. Okay, so this will also give you full credit. Number 5, what is the projection of A onto B? What is the magnitude of this projection? For these, you probably should learn the formula for the projection. Okay, remember it has a dot product on the top and the bottom. And I just want to point out again, if you're trying to find the projection of A onto B, almost everything you write is B, right? So you have A dot B on the top, everything else is a B. Okay? B, right? So A dot B over B dot B times B. And then you just calculate, right? The dot product happens to be -5, and then the denominator is, it is a square of the magnitude of B, and that turns out to be, well, that's -5 over 3, and then you multiply that. So in other words, this whole thing is a scalar, right? The only vector portion of this is this, that's your B. And so you multiply that scalar, -5/3 with B, and that is your answer. This is also acceptable, of course, just multiplying this out. Now the projection, okay, the projection is of course the length of this. And this can be taken, you can take out the -5/3 and find the absolute value. Everything else is 1, so it's a square root of 3 multiplied by 5/3. That's a fine answer. But there's a formula for the scalar, or the length of the projection. Sometimes it's called a scalar projection. A scalar projection simply means the length of the scalar, length of the projection. And we had I tell you what, I think this is kind of an important part, and I'll just tell you what we mean by this, right? So if this is your A and this is your B, the projection, we're talking about this length, right? Right, that length is, of course, the norm of A, that's the hypotenuse, times the cosine of theta, right? I mean, this is straight from day 1 of your trigonometry class. And of course, that's okay, except you don't know what cosine of theta is until you do the dot product and all that. So you can just go ahead and add this as long as you do the same thing in the denominator. Well, see, that itself is the length. Now, this is closely related to this formula, of course, right? But this is the length of the, and actually you should have an absolute value here because it's the length. But this you can calculate, right? So this turns out to be, again, you can see the top is the absolute value of the norm of A times the norm of B times the cosine of theta, that's A dot B, and divided by the length of B. So if you use this formula, which is this, then of course you get the same answer, 5/3 over the square root of 3. Okay, number 6, explain the direction and the magnitude of the cross product of any two three-dimensional vectors. This is the kind of problem I really like to ask you on your test, and probably like on the final exam as well, okay? Because, I mean, this is a concept question, and it doesn't just, tell me that you know how to calculate these things. It also tells me you understand what the cross product is. Okay, so the cross product of two three-dimensional vectors is, of course, a three-dimensional vector. And what I wanted you to tell me, or what I want you to answer, is that the magnitude is the area of the parallelogram with those two vectors being adjacent sides. And the direction is the what? Perpendicular. This is very important, right? And we have used this fact over and over again already in the first part of this chapter. In order to get something perpendicular to two given non-parallel vectors, you take the cross product. So the direction of the cross product is perpendicular or orthogonal, synonymous, to each vector, and in accordance with the right-hand rule. And so again, you should remember what the right-hand rule is. If this is U and if this is V, remember your right hand is sort of like this. It's a terrible right hand. All right. But anyway, you're wrapping your fingers around this way, like that. And so your thumb is pointing upward, and this is the right angle, and this is also the right angle, and that is the answer to this question. Make sure you know that the cross product is primarily used to find something orthogonal to both given vectors. Fairly important. Okay, number 7, find the volume of the parallelepiped. Stop here. The volume of the parallelepiped, as soon as you see that, you should remind yourself, okay, it is about that scalar triple product. And so you take the scalar product, which is a triple product, and basically, I mean, this is it, right? It's A dot B cross C, but it also turns out to be B dot C cross A. It's also C dot A cross B. I know it's kind of weird. You can find B cross C first, and here's your B cross C, and then you take the dot product. But I hope you didn't, I hope you got this in the lecture videos. You could do this in two steps. But remember, when you take the dot product of this and this, it's basically, you can replace this first row with your A, and you take the determinant of this 3 by 3 matrix, and that's going to give you the same thing. The answer is 25. Now, this particular situation, the triple product turns out to be negative, okay? And so you just take the absolute value. And the reason turns out to be negative is because, well, B cross C, if you did C cross B, then it would not have been negative. Somehow we did this orientation in the opposite way. And so what this is showing is, how do I say this? You have this parallel pipe like this, right? And there's an order in which you have to label these. And unless you follow the order, the answer turns out to be negative. It's basically sort of calculating the backwards, the opposite, but you don't have to worry about why this is negative. It just happened to be that this particular order we picked, B cross C, as opposed to C cross B, gave you a negative value. All right, number 8. Find parametric equations. Here. Okay, this is starting 2.5, right? Find parametric equations of the line through Q and R. Okay, so I see Q and I see R, and so let's find how you would do that. QR is this thing, right? So remember what you have to do here is I mean, this is the picture. You have Q and this is R. It doesn't matter if you find QR or RQ. This is the vector we use, which is parallel to the line, of course, right? So you need a point and you need a vector parallel to the line in order to write down the equations. Well, you found QR and you found actually 2 points, but you can just use 1 point. If you pick this point, this is the set of parametric equations you get. If you pick this point, you get this parametric equations, this set of parametric equations. Either one is completely acceptable. And as you know, as t goes from negative infinity to positive infinity, these will give you exact same sets, right? Same set of points. And so the only difference is, if you plug in t is equal to 1 here, you actually get this, right? When t is equal to 0, t is equal to 1, those will give you the same point. And so that is the only difference. Either one is just fine. Okay, number 9, find the equation of the plane. All right, so think. Let's go back to equation of the problem 8. If you have to come up with equations of a line, a parametric equations of a line, you should know it looks like this, right? And then you should know 1 point that would give you these 3 coordinates. And then you need a vector that will give you the coefficients for the t. And so you need 1 vector and a point. Okay, that's how you can find a particular line. If you're looking for a plane though, you need what in order to describe a plane or to come up with an equation of that plane? Yeah, you need 1 normal vector and a point, right? So keep these things in mind. For number 9, oh yeah, so another thing about number 9 is you're supposed to find the equation containing 3 points, okay? So you have P, Q, and R. And so how do you find this normal n? Well, remember, which problem was that? It is this problem that gives us a clue to this one, right? Because how do you find n that is perpendicular to this plane? Well, find PQ and find PR, and then you take the cross product. And that's exactly what I do. PQ and PR, take the cross product of these, which we already did, by the way, in an earlier problem. And so you can plug this in to the formula. But here's a little trick, and I think you should be familiar with this trick because this will make questions a lot easier. Sometimes these numbers are really big. Now, all you need is 1 normal vector that happens to be, what I mean by a normal vector is it must be perpendicular to the plane that I would like to describe. And all that means is any scalar product of this is okay. Well, simply try to divide everything by a nice number, and let's simplify this. You think you can do that? What would be a good constant to divide each coordinate by? I mean, I would think of like -3. So let's go ahead and use this, n, okay? And so using this n111 and easy point 004, you plug in 004 here, 111 here, and then make sure you have the right-hand side because that's what makes this into an equation. And then this is your answer, okay? Now you can also use, instead of R, you can use P or Q. And this part will look very different, right? But once you simplify this to this kind of a form where one side is equal to 0, whether you use P or Q, that will look exactly the same. In fact, you can use -3, -3, -3, all right? And if you come up with this form, you will just have this whole thing multiplied by -3. So at the very end, you can divide the whole equation by -3. Anyway, you will always end up with this simple form. And so that is probably the best solution here, even though I will still accept, this solution here as well. Okay, so how far did we go? That was number 9. Let's go to number 10. Find an expression for the angle between plane 1 and plane 2. I've given you these 2 planes here. So try to imagine a plane crossing like this. Okay, this is a nice way to think about this. Plane 1 and plane 2. What's an expression for the angle between them? Now remember, you're trying to measure this angle here, but that's the angle between these 2 normal vectors as well. So all you have to do is to come up with the an expression for the angle between N1 and N2. And N1 and N2 are, it's right there. I mean, you don't even have to work hard or think hard. Just read off these coefficients, right? N1 will be 2, -1, 1. N2 is 1, 3, -1. Why? Well, because these coefficients are the normal vectors, right? This is just fabulous. It's very nice the way it works here. So plane 1, here's a normal vector. Here's plane 2, the normal vector. Take the, well, trying to find the angle between them. And that's exactly what you are doing on problem number 1. So the cosine of the angle is the dot product divided by the norm of the first times the norm of the second. Now, the only difference is, now be careful with this, the only difference is, here I didn't have the absolute value on the top. Why not? Well, because two vectors can possibly be apart by an obtuse angle, right? We always measure this less than 180 degrees. All right, if you go to two planes meeting with each other, where am I? Two planes meeting with each other, you know what the difference is? Here. When two planes meet each other, okay, you can measure this angle or this angle. Well, you always measure the smaller angle. That's how we talk, right? When you see two planes meeting at, let's say, 30 degrees here, we normally don't say, well, the angle between them is 150 degrees. You don't choose that part. So when two planes meet, we can always assume that the angle of intersection is the acute angle. I mean, it could be a right angle, but other than that, it should be the smaller of the two angles. And that's why we take the absolute value because the acute angles have the cosine, the value of cosine of an acute angle is always positive. And it is the opposite of the corresponding complementary angle, right? So the cosine of theta is this. So the answer for theta is the inverse cosine of that, okay? Now that's a very small number, by the way, which tells me that, what does it tell you if the angle is smaller? This number is close to 0, and so the theta is going to be close to 90 degrees. If it is 0, then of course theta is 90. Okay, number 11 is next. We're almost done with this. Write parametric equations for the line of intersection of plane 1 and plane 2. So how do you do this? Find the parametric equations of the line of intersection. We are talking about, what line are we talking about? Clearly this line, right? Well, I mean, this line here. So the one, I mean, so again, what do you have to know, or what do you have to have in order to write equations, the parametric equations of a line? I need one vector and a point, right? And we don't have either of them right now. So first we have to find a point of intersection between this plane and that plane. And there are, of course, infinitely many of them, because every point on this line is clearly an intersection point. And then the direction, the vector, can be found by what? Well, it has to be perpendicular to N1, since this plane, this line lies in the plane 1. This also has to be perpendicular to N2 because it has to be on this plane. The line of intersection is also a part of P2, right? So you have to take the cross product of N1 and N2 in order to find this vector along the line or parallel to this line. And so that's what I do. First, let's take the easier part, okay? Because what's easy is, yeah, so you take the cross product of this, right? And then you get your vector that's perpendicular to both N1 and N2. Okay, that part is done. That's an easy part. The second thing is to find any common point of intersection. And so all you have to do is to set up the system of linear equations where you have these two equations of lines, right? And then find just any point, okay? And in this case, you know this plus z and minus z. So you can just, add the two equations. This will give you that one equation. And that's pretty much it. What's the solution? Well, there's no one solution, right? Because the solution is really the infinite many points, which constitutes that line. So at this point, this is the only requirement. So you just draw, pick a point, okay? What point? You can let x be 0 or y be 0. I think it's easier in this case to let x be equal to 0 because then y is 1. And you plug in these numbers and that will give you z is equal to 4. Now this is not the answer, of course, right? Because this is just a way to find one point. And once you decide what x and y are, you have to plug this into one of these equations. I don't care which one. You plug 0 and 1 for x and y respectively, and then you find z is equal to 5. So you found one point, 0, 1, 5, to be on the line of intersection, and the line of intersection is parallel to this vector. Now you can write your equations. So technically there's a 0 here, of course, right? And then 1, 5, and then negative 2, 3, 7 appear as coefficients for t. All right, then the last two questions have to do with distances, right? All right, so these are pretty important questions as well. Find the distance between R and plane 2. So you have this plane 2 and R, which is 0, 0, 4. How do you do this? Okay, so this is a nice picture, and then I personally draw a picture like this every time I do a distance problem, because then that makes it easier for me to remember the formula. And if I forget the formula, I'll start drawing a picture like this, you know, and say this is D, this is D. How do I need this? How do I find this? Well, this is going to be, and here's the angle. That's also the angle, right? So that D has to be the hypotenuse times the cosine of the angle, and that's how we remember this formula. Or you can just know your formula here, and that is the dot. So pick, I forgot to tell you first, pick some random P first on the plane, right? That's a weird way to start a problem, but pick any point, and then find PR. In this case, PR is 0, 0, 2 because I picked this point here. And so then all you have to do is to take the cross product of the dot product of PR and this normal vector, which we know is 1, 3, negative 1, right? There it is. Take the dot product of this, and that's going to give you a negative 2. And then you divide it by the length of the normal vector, right? And so that is your answer. Of course, you have to have the absolute value in the front because theta, the top, because theta could be negative, be obtuse, and in which case the cosine would be negative. But remember, if you forget this though, you can always remember D is the hypotenuse, which is the norm of PQ, times the cosine of theta, right? And remember, this theta is the same as this theta here because these are the alternate interior angles. Well, that's good, but if you just put n on the top and the bottom of the norm of n, you can tell this thing here, and by the way, this is supposed to be the absolute value. This thing here is the dot product, okay? And so you can easily recall or recreate or reconstruct the formula on the spot, even if you forget. And that's why I drew a picture like this. And then finally, number 13, use your answer from problem 8 above. That's your parametric equations of the line, QR, and find the distance between P and QR. So how do you do that? Here is the picture. You have P, and then you have QR. Q is somewhere like here, right? And so here's what you need to find out. I need to find the distance here. How do you find the distance? So by the way, in equations of lines, what's obvious is not normal vector. It's a vector parallel to it, right? So in order to find, this vector, and if you pick a random point, in this case R, then you know PR, and then the angle between those two known vectors is this part here. And with respect to that part, the distance we want is actually the opposite, right? And that's why you use the one that's involved with cosine, because the distance D is the length PR times the sine of the angle theta. And the sine of the angle theta is the one that is involved with the cross product. In fact, the cross product, see in this case, I have V and I have RP, right? So V cross RP. What is V cross RP? the norm of the vector, in fact, the magnitude of this cross product turns out to be, remember, it is the norm of V times the norm of the second vector times the sine of the angle between them, right? And so you can tell that D, well, look, D is, and again, just looking at this, it's really the length of PQ times the sine of theta, right? That's what you get from this triangle. And so you kind of wish, it would be nice if I can just put a V here, because then I will have this expression on the top. Yeah, I can just go ahead and do that as long as I do the same thing on the bottom. And this tells you then the top is V cross PQ, the norm of that divided by the norm of V. Again, if you forget this formula, you can just reconstruct it on the spot if you remember how to do that. So, and of course, for your test, you probably want to memorize this, okay? And the thing is, you don't have to memorize this forever. After this test, you probably can forget that because you can also recreate this. And Calculus 3 is not about finding distances, right? So you probably will not be using this very often for the rest of this semester. But for this test, I want you to know how to do 12 and 13. Okay, so finally, know the operations and what comes out. For instance, if you take the dot product, you know the answer is not a vector, right? It's a number. You should also know how to sketch and describe a region in three-dimensional space. So if I say z is equal to 7, what is that? Well, that's going to be a horizontal plane, right? If x is equal to y, right? Z is irrelevant. What do you get? It's going to be a vertical wall, okay? And it's going to be a vertical wall that is on top of this line. Okay? So in the three-dimensional case, it'll look like this. And okay. But anyway, so know some basic equations in 3 dimensions. That's it. I went through this fast, but you have this checklist, or this is the practice test 1. Okay, as well as the solution without all the messy handwriting. So, and this is found in the module for chapter 2. And so I hope you will study and be ready for your test. Okay, have a wonderful day, and I will see you soon.